It's Monday and woohoo! It's the last week for us to do some DMA online. So let's go ahead and let's get started with some practice problems and let's warm our brains up with our math. So let's take a look at our first problem. It's a fraction problem, and we know that we are going to use a less than, greater than, or equal symbol to make this statement true. Okay, so I'm looking at my first whole circle here, and I notice that this circle is broken up into 4 equal parts. Now that tells me my denominator is fourths. And I'm assuming I'm looking at my shaded parts, right? And I notice that I have one of those parts that are shaded, so that is my numerator. So I have 1/4 of the whole circle shaded in here. Now, if you look at this piece right here, or this whole circle is broken up into 1, 2, 3, 4, 5, 6, 7, 8 equal pieces. Now, you may have already noticed, and I hope you have, that each one of these fourths can be partitioned into 2 more pieces to make eighths. I hope we remembered that. So remember, when we use our fourths, we can cut those into 2 more pieces to make eighths. So let's take a look at, I've got 2 of my eighths shaded in here. So 1, 2, 2 eighths. Now looking at my shaded piece here and the shaded piece here, remember it takes 2 eighths to make 1/4, 2 eighths to make 1/4. And so we can say that these are equal or equivalent to each other because 2 eighths is the same as 1/4, which are equivalent. Okay, so hopefully you remember how to place this on a number line. So looking at a number line, and if I had this on a number line from 0 to 1, and remember to get fourths, we start at the halfway point, right? Half. So I'm going to put this as a purple line down the middle here. And then from there, I can use those halves to make fourths, if you remember. So 1, 2, 3, 4. So this is 1/4. This is 2/4, or it's also half because 2 is half of the 4 pieces. We have 3/4, and 4/4 is 1 whole. Now from here, we can use our fourths to make, right, you got it, eighths. And so I'm cutting each one of these fourths into 2 pieces. That's 2 eighths, another 2 eighths, another 2 eighths, and finally 2 more eighths. So I have 1, 2, 3, 4, 5, 6, 7, 8 eighths. And remember, 8 eighths is 1 whole, right? So now here's my 1/4, and here are my 2 eighths. Oops, sorry, eighths. 1/8 and 2 eighths. And this would be 3 eighths, 4 eighths, 5 eighths, 6 eighths, 7 eighths, and finally 8 eighths. Notice that this 1/4 is exactly in the same spot, or the same amount from here to here is the same amount, which is 2 eighths and 1/4. All right, let's take a look at our next problem. It's a time, and it's a lapse time. So it says at 10:35, Sasha started watching a trapdoor spider. Ooh, that's kind of cool. She watched for 43 minutes until it caught an insect. What time did it catch an insect? So we have a start time. We have the elapsed time. We want to know what time is our end time. So I'm just going to move my paper up just a little bit, and I'm going to show this on a timeline. And I know that I'm starting at 10:35, and I'm just going to assume that this is AM. And the reason I'm assuming it's AM, I guess, is because I don't know that I would sit and watch a spider at 10:35 p.m., but I guess it could happen, right? All right, I'm going to add 43 minutes. Now, there's several ways that you could do this. You could break it up as 20, 20, and 3, or you could break it up as 10, 10, 10, 10, and 3, or you could break it up as 30 and then 3. It's up to you, but I'm going to start off with 10, and I'm going to add on 10 minutes, and that would put me at 10:45. If I add on another 10, that places my time at 10:55. Now, 10:55 means that I'm getting close to that next hour. So if I add 5 and 5, that makes 10. Then now I'm at 11:05. And I'm going to need to extend my timeline here just a little bit. Just going to scoot over just a tad. I'm going to need another 10. That puts me at 11:15. And now I'm going to add these 3 more minutes in. And that puts me at 11:18. So the time that she or the spider caught the insect would be at 11:18. And I'm just going to put AM here because I'm inferring that they are using this time in the morning. Okay? All right, let's take a look at our third problem. It's a word problem. And it says Matt has 28 baseball cards to give to 7 friends. Now notice it doesn't say Matt has 28 baseball cards for each friend. He's not giving 28 baseball cards to each friend. He's taking his total baseball cards and he's giving the same number to each friend. How many cards will each friend get? So he's sharing. And when we talk about sharing, we know that we are putting them into equal groups. So I'm going to take these 8 cards and I'm going to share them equally into groups, which are my friends. And I'm going to look for how many cards for each friend. Now, what this tells me is I know how many friends I have. I don't know how many cards each friend is going to get, but I do know how many total cards I have. So I'm looking for the number of cards each friend is going to get, and the total that they have together is going to be 28. So I'm just going to flip to my back here, and I'm just going to show this as a model. And I know I have 7 friends. And I'm going to take my 28 cards and I'm going to break them up into or between the 7 friends. So I'm going to take these 28 total cards that I already know that I have, and I'm going to separate them into the groups. Now, again, if you know your multiplication facts really well, and this is why I keep telling you guys, practice those multiplication facts. You would know how many cards would you need to finish up this multiplication equation. Okay? So 7 groups of what equals 28? Well, I'm going to go ahead and put 1, 2, 3, 4, 5, 6, 7. Okay? 8, 9, 10, 11, 12, 13, 14, which is another multiple of 7. 16 or 15, 16, 17, 18, 19, 20, 21, our next multiple of 7. And finally, 22, 23, 24, 25, 26, 27, and 28. So as you notice, there are going to be 4 cards for each friend. So if I take my 28 cards and share them equally between my 7 groups, there are going to be 4 cards for each friend. And that's how multiplication is the opposite of division. Here we have our total, and we are going to share them equally into the groups, which are the friends. Okay? All right, that is our model equation, and now you can write your response. And finally, we have a pictograph here. Remember, always look at your key on a pictograph. And it says, flowers in my garden. We have daisies, roses, and sunflowers. So remember, this key right here is very important. It tells us that each picture is the same as saying 2 flowers. So how many daisies does this person have? Well, this is 2, this is 4, this is 6, and this is 8. So notice, I haven't even looked at my question yet. I'm just looking at what does my pictograph tell me. Here I have roses, I have 2, I have 4. Now this is half of 1. So since it's half, I'm going to take half of these 2, which is 1. So this would be 2, 4, and 1 more makes, right, 5. And sunflowers, she has 2. Now my question asks me, how many flowers are in the garden in total? So, hey, I already have this pretty much figured out. Because if I take my daisies, which are 8, my roses, which are 5, and my sunflowers, which are 2, I get my total by doing what? Right, adding them together, right? So I add 8 plus 2, because I like 10s, and 8 and 2 makes 10, and 5. So 8 and 2 is 10, and 5 more makes 15. So her total flowers are 15 flowers. Now, here's a tricky question for you. If she takes her 15 flowers and she puts them equally into 3 vases, how many flowers will she need to put in each vase? So this is tricky because I'm taking this information now and I'm having you think about how you would divide those flowers up into 3 vases. How many flowers will be in each vase? Okay, I can't wait to see what you guys come up with. I'm sure you guys will figure this one out. Have a great day, and I'll see you in our live meeting today. Bye.